Sometimes everyone isn't really everyone. Like when people say, everyone's on the internet. Because the truth is, for each person that can get online, there are two that can't. And when you look closer, that everyone looks even less like everyone. In some places, it's more like 1 in 1,000. In others, it's 1 in 10,000. And in some places, no one's online at all. But what if there was a way to light up the entire globe and finally make all the world's information accessible to all of the world's people? Well, even though today 1 in 3 kids can't get to a real secondary school, everyone could have secondary school come to them. In places where there aren't enough doctors, everyone could be helped by doctors in other places. Farmers everywhere could start using better weather data, so everyone could enjoy a bigger harvest. And because small businesses that are on the internet grow twice as fast, everyone could create new opportunities for everyone. But how do we bring affordable internet to everyone? Maybe finding an answer starts with looking somewhere new. Like up, and trying something different, like balloons. Yep, that's right, balloons. Because it turns out that if you use balloons, it's faster and easier and cheaper to give everyone the internet than it is to give some people the internet. That's why we're giving it a try, and why there's hope that someday soon, everyone really will mean everyone.
Inside the massive hangars at Moffett Federal Airfield, Google is attempting to do something that balloon experts deemed impossible: deliver high-speed internet access to the most remote corners of the globe.
The first 60 or so balloons we launched all burst when they got to altitude, which was very sort of disheartening.
This is something that has never been asked of balloons before, to be reliable and to do what we expect them to do. Before, it was just sort of like a vehicle to gain knowledge. Now we're trying to make a business.
Launched in 2012, the first 2 years of Project Loon were a process of rapid iteration. The team had to prove it was possible to deliver reliable internet access to specific locations in the most remote parts of the globe. They began with the simplest possible approach: electronics stuffed into a styrofoam beer cooler floating at the edge of outer space. When that didn't fail, they kept moving forward.
The way Google X works is we try to prove that it can't work. So the first thing we did was took a router, flew it on a weather balloon up to 10 kilometers and see if you could still get a signal. And that part worked. And since then, it's been a continuous process of trying to stretch the envelope a little bit more every time to see how far it would go.
Last year, the team made a critical decision: switching from a wireless router to an LTE antenna.
We are just like a cell phone tower, but in the sky. And the same way that their central office of the telco interacts with all their cell towers, they will interact with our balloons. Another way to think about it is, if you drive down the highway on a phone call, you will switch between cell towers. What we're doing is kind of flipping that on its head. So you're standing still on the ground with your LTE phone, and as one balloon goes overhead, another balloon comes in range, and you're switching between one balloon to another without dropping the call. The balloons today can cover 5,000 square kilometers on the ground. You can get 15 megabits per second to your phone, or if you have a little MiFi device, you can get 40 megabits per second from the balloon.
So have you guys considered just selling this as like a toy for children's parties and stuff?
Yeah. I'm gonna need the hanger to go with it.
Yeah. So Mahesh, tell me what it is we're seeing here.
What you're seeing here is a test of our next generation balloon. We are doing a ground-based inflation, trying to mimic what is happening in space.
I remember when we were building balloons, it would take us a week to build them, and they would go up and pop and come back down.
When we first launched, it was pretty nerve-wracking. Our balloons were lasting anywhere from a day to day and a half, maybe 2 days. If you had like a 5-day balloon, it was like eureka. But as we went along, one of the first objectives was, what is our goal? Our target is 100 days, ideally, for us to have a very commercial business here.
I have a fashion design degree. It's a lot of working with textiles, flat patterns, working into three-dimensional space. We do a lot of different tests with balloons built in different ways. They might be a different shape, they might have an extra feature, we might change the dimension of a feature and try and figure out what works and what doesn't.
Rather than reinventing and starting all over from the start, we were looking for industries where we can actually leverage information from. One of the areas we looked at was food packaging industries, agricultural industries, even down to the condom industry. And so these are the places where we need to actually figure out even the tiniest pinholes that matter can actually limit the lifespan of the balloon by like 15, 20 days.
Our longest lasting balloon was up for 173 days until we brought it down. Now we've gotten to the point where most of the balloons will last over 100 days.
Done.
Here we go, and we're awake. Ta-da! Don't put your fingers in there.
Yeah.
What you're seeing is a balloon inside a balloon. We have a unique way of actually adjusting the altitude in these balloons.
This balloon has a constant volume, and there is helium in it, right? So the helium brings the balloon up. And now, if we want to change altitude, we have another balloon inside the balloon that we fill with air. And as we add more air in there, the mass is going to increase, and the balloon is going to go down.
Okay, this is called Hans, and we named it that because there was a Saturday Night Live skit, which was Hans and Franz, that's gonna pump you up. And what it does is it's a little fan, and it pumps air into the balloon. It's easy to steer the balloon by picking up different winds and different wind directions at different altitudes.
By doing small change of altitude, you can do something like this. You go up, use this wind, then go down, use this wind, and go up, down, up, and down.
So this balloon has straps holding the apex up, and that balloon did not.
Right, which is why it's sitting down there.
Yeah, because yesterday when we were filling it up, it got in a twist to the point where it just did that. That's what happens. There you go. So we just popped the ballonnet because it was twisted. That was the test here.
Over the last 6 months, Google has run tests with Vodafone, Telstra, and Telefonica, utilizing their networks to provide connectivity to customers who normally live with little or no internet access. Loon believes that it can provide service to these remote regions at a fraction of the typical cost.
Communication satellites are typically pretty expensive, hundreds of millions of dollars to build and 100 million plus to launch, whereas the balloons are an order of magnitude or two cheaper to operate on a sort of daily basis. It's too expensive to build wires and cell towers and fiber optics out to all these remote rural regions, but the balloons are very cost effective. This gives the telco a way to reach everyone in their country with a cost-effective way.
Right now, Loon mostly operates in the southern hemisphere, where it's had better luck securing overflight permissions. But the project has potential applications for developed nations with widespread internet access as well. Because the balloons live in the stratosphere, they have a unique advantage over terrestrial internet infrastructure.
There's no weather in the stratosphere, which means if there's a hurricane or a typhoon that knocks out power or internet connectivity to people on the ground, even in places like Japan or China or other places around the world, the balloons provide a very exciting ways to immediately let people have connectivity 10 seconds after the natural disaster occurs. As long as they have a battery-powered phone in their pocket, people will be able to instantly get access to the balloon network. Sometimes people think of Google X as a research lab that's not necessarily a business, but that's not true. All of the projects on Google X have to have a business plan, a business case, and the business case for Project Loon is really exciting. It's still early stages in our project in terms of figuring out how big it can grow. It's great for bringing internet to 4 billion people on Earth who don't have it and bringing all the benefits, education, medical information, weather reports, but it's also a business in itself, a very good business. If many of these 4 billion people even paying what they can afford, 1 or 2% of their monthly income, can now afford to have internet access, and it's a very good business in itself. Increasing the internet penetration by 10% in a country will increase the GDP by about 1.4% per year. So in many ways, technologies that can increase internet penetration of 10 or 20% can double the growth of standard of living of half the countries in the world.
It's a big thing.
Yeah, it is.